Now we're moving to equation of a straight line. We spent some time doing gradient in the last session. Now let's see what happens when we draw the graph of this and figure out how to extract the gradient given the equation of the line. To draw a graph, you will need a table of values. You pick your values for x, make sure they are numbers that are easy to work with. So try pick some positive and pick some negative. In the exam, if they ever ask you draw the graph of this function, you will need to draw yourself a table like this. You pick your values for your x, but your y depends on the values of your x. Let's start with the positive. If x is 2, that means you have 2 times 2 here, which is 4. 4 plus 3 is what? 7. Now, if x is 1, it becomes 2 times 1, which is 2. So this is 2 plus 3. That is 5. When x is 0, it becomes 2 times 0, which is 0. 0 plus 3 is 3. When x is minus 1, it becomes 2 times minus 1, which is minus 2. And minus 2 plus 3 is 1. You can already see a pattern. It's going 7, 5, 3, 1. It's going down by 2 each time. With a straight line, it always has some pattern. So if you've done the first 3, you can predict the next set of numbers. Now that we have the table of values, we plot our graph. I'm going to plot this onto here. If x is minus 1, y is 1, right here. When x is 0, y is 3. This is where x is 0, but y is 3, right here. When x is 1, y is 5. Take it right here. When x is 2, y is 7. Take it all the way here. And then you want to grab your ruler and draw a straight line to connect this point. Based on what we have learned so far, from this line, I can work out the gradients. I can pick 2 points. This was 1, 5. I can pick that point. I can also pick this point here, which was 2, 7. And then draw my triangle. The difference in y is 2 and difference in x is 1. So the gradient equals 2 over 1. It's a positive gradient, which is 2. Do you notice any from this gradient and this equation? Can you see any link with this equation? All right, let me break it down. This 2 here is the 2 here. Whatever gradient you get for your straight line, that gradient would always be the number before the x. So whenever you're given the equation of a line and you're told to find the gradient, you do not need to plot graph. You just look at the number before the x, provided it's written in this form, y equals mx plus c. Your m here is your gradient. You can read off the gradient without drawing a graph like this. Also, and look closely at this red line. Where does it cut the y-axis? Exactly, it cuts it at 3. Again, look at this equation and tell me what you notice. It means that wherever the line cuts the y-axis must be that number, because it's plus 3 here. It means it must cut the y-axis at 3. If it's minus 3 here, it must cut the y-axis at minus 3. Minus 3 somewhere around here. This is called gradient, and this is called your y-intercept. Every straight line has this equation. If it doesn't look like this, then it's not a straight line. For example, y equals x squared plus 8. This is not a straight line. Do you know why? Because this one has a square, this one doesn't. But if I have something like this, y equals 3x minus 8. This is a straight line. I don't even need to draw the graph. I know this will be a straight line because y, m, x. The plus is a minus, but it's okay. Plus, and then the c is minus 8. Y-intercept. It means that if I draw the graph of this function, it will cut the y-axis at minus 8 and the gradient is 3. What if I have something like this? What is the gradient of this line? And what is the y-intercept? What's the gradient? You see, this is 2y, but we said the equation must look like this. Why? This one has 2 in front of it. So you need to get rid of these 2 by dividing all through by 2 first, so that it then looks like y equals, and now you have 4x plus 5. Then you can read off the gradient. So what's the gradient and the y-intercept? 5. Lovely. What is the gradient of this line? Gradient and the y-intercept. You need to now write in this form. So who can help me? Make y the subject. Before you divide by 2, can you arrange it this way? So that y is on this side, equal sign, then x, and then c. You got 10y equals 16 minus 4x. Can we try and rearrange this so that the x is on this side? So we've got 10y equals minus 4x plus 16. I've just moved them round. Now, what can we do? I divide this by 10 and I divide this by 10. Your focus is to get y all by itself. So get rid of that 10 before the y. You've got y on this side now because this will cross off. And then here would be what? Minus 2 over what? 5x plus what goes into 16 and so 8 over 5. What's the gradient? Minus 2 over 5. And the y-intercept? Positive 8 over 5. This is a very interesting one that you get given in GCSE. And they would ask you to work out the gradient and y-intercept. You must rearrange it so that it looks like y equal. You must have y equal and then something x plus something. Yes, you can do a decimal, but I always try to tell my students to only use decimal if you're sure your conversion will be correct. I think I have covered a lot. We have looked at drawing a straight line graph by creating a table of values and then plotting the graph. And we have established a link between when we find the gradient of our straight line and given the equation of that straight line. What can we notice? We see that the number before the x is always the gradient, provided you have the equation written as y equals mx plus c. And we also figured that the number just after the x is the y-intercept. So in this case, you can see positive 3. And then we looked at some sample questions of where we'll be given equations and told to find the gradient and y-intercept. Some cases they are obvious, in some cases they're not. So you've got to make sure you know how to go about that.